Right now, as you watch this video, something is happening that scientists still cannot fully explain. Our entire galaxy, all 400 billion stars of it, is hurtling through space at over 1 million miles per hour. The Milky Way stretches across 100,000 light-years of cold void, containing planets and moons and asteroids and comets, gas clouds and stellar nurseries and dying suns. But here is what keeps astronomers awake at night. Everything you just pictured, every star, every planet, every grain of dust, accounts for only 15% of what's actually here. The other 85% is something we cannot see, cannot touch, cannot detect with any telescope ever built. And it is not floating somewhere out there in the distant cosmos. It is right here, wrapped around our galaxy like invisible chains. We are not just living in the Milky Way, we are prisoners inside something far, far larger. Scientists call it dark matter. And in January 2026, researchers led by Sukanya Chakrabarty at the University of California, Berkeley, announced they had finally detected something impossible. A massive clump of this invisible substance lurking near our own solar system, warping the fabric of space-time itself. This is not science fiction. This is happening in your cosmic backyard. The question is no longer whether dark matter exists. The question is what else is hiding out there that we have not found yet. And that question might terrify you by the time we are done. To understand how we got here, we need to go back to 1933, to a Swiss astronomer with a terrible reputation and an even worse temper. Fritz Zwicky was brilliant, abrasive, and nearly impossible to work with. His colleagues at Caltech kept their distance. He had a habit of calling other scientists spherical bastards, because as he put it, they were bastards from every direction you looked at them. He feuded with nearly everyone in the astronomy department. He submitted papers that were often rejected not because the science was bad, but because nobody wanted to deal with him. But Zwicky had one quality that his critics lacked. He was willing to follow the evidence wherever it led, even when that evidence pointed somewhere absurd. And in 1933, looking through his telescope at the night sky above California, Zwicky saw something that nobody else was paying attention to. He was studying the Coma Cluster, a massive collection of over 1,000 galaxies located about 300 million light-years from Earth. When Zwicky measured how fast these galaxies were moving around each other, he found something deeply wrong. They were moving too fast, way too fast. Based on how much matter Zwicky could actually see, those galaxies should have been drifting slowly, lazily orbiting their common center of mass. Instead, they were screaming through space at velocities that made no sense. At those speeds, the Coma Cluster should have flown apart billions of years ago. There simply was not enough visible matter to hold it together. Zwicky did the math over and over. The numbers kept telling him the same disturbing thing. There had to be something else there, something massive, something invisible. He called it Dunkel Materie, dark matter. The scientific community laughed at him. For decades, Zwicky's dark matter hypothesis was treated as the ranting of an eccentric outsider. Mainstream astronomers had no use for invisible matter that could not be detected. The idea was absurd, unscientific, embarrassing. And then, in the 1970s, everything changed. Vera Rubin was an astronomer at the Carnegie Institution in Washington. Unlike the combative Zwicky, Rubin was quiet, methodical, and relentlessly persistent. She had spent years being underestimated, dismissed, and overlooked because she was a woman in a field that did not want her there. Princeton's graduate astronomy program did not admit women when she applied. She was told to sit in the back of the classroom at other institutions. Colleagues assumed she would quit once she had children. She did not quit. Instead, Rubin quietly built one of the most important data sets in the history of astrophysics. And in the 1970s, she was about to break physics wide open. She was measuring the rotation curves of spiral galaxies, specifically how fast stars orbit around the galactic center at different distances. According to everything physicists understood about gravity, stars at the outer edges of galaxies should move slower than stars near the center. This is how orbits work. Mercury orbits the Sun faster than Neptune because it is closer to the Sun's gravitational pull. Rubin expected to find the same pattern in galaxies. Stars near the center should move fast. Stars at the edges should move slow, but that is not what she found. When Rubin mapped the velocities of stars in galaxy after galaxy, she discovered something impossible. The outer stars were moving just as fast as the inner stars, sometimes faster. This should not happen. It violated everything scientists knew about orbital mechanics. Unless there was mass they could not see, a lot of it, spread throughout the galaxy and extending far beyond its visible edges. Suddenly, Fritz Zwicky did not seem so crazy anymore. Rubin's observations forced astronomers to confront an uncomfortable truth. Either our understanding of gravity was fundamentally broken, or the universe contained vast amounts of invisible matter that we had somehow missed. And by the 1980s, the scientific consensus had shifted. Dark matter was real. Today we know that the Milky Way is not just a disk of stars floating through empty space. Our galaxy is embedded inside a spherical halo of dark matter that stretches nearly 2 million light-years in diameter. To put that in perspective, the visible part of the Milky Way, all those stars you see on a clear night, is roughly 100,000 light-years across. The dark matter halo surrounding it is almost 20 times larger. Estimates published in the Astrophysical Journal suggest this invisible structure contains roughly 1.3 trillion times the mass of our Sun. The visible stars and gas and dust we can actually detect make up maybe 15% of that total. We are not living inside a galaxy. We are living inside a dark matter ocean, and the galaxy we see is just a small island floating at its center. And here is where things get strange. The European Space Agency's Gaia spacecraft has spent years mapping the precise positions and motions of over 1 billion stars in our galaxy. When astronomers analyzed this data, they found something disturbing. The Milky Way is not alone in its dark matter halo. There are other structures in there. Smaller dark matter clumps, invisible satellites that orbit our galaxy like moons orbit a planet. Scientists call them subhalos. And some of them contain galaxies that failed. Ghost galaxies are exactly what they sound like. When the universe was young, dark matter clumped together under its own gravity. These dense knots of invisible matter became the scaffolding on which normal matter would eventually collect. Gas fell into the dark matter wells, compressed, heated up, and ignited into stars. But not always. Some dark matter clumps were too small. They pulled in gas, but never quite enough to trigger star formation. These structures became ghost galaxies, vast halos of dark matter containing almost nothing visible. In 2024, researchers at the Harvard-Smithsonian Center for Astrophysics announced the discovery of what they called Cloud 9. It appears to be the remnant of a failed galaxy, a structure made almost entirely of dark matter that drifted too close to the Milky Way and got torn apart by gravitational forces, the bones of a galaxy that never lived. And Cloud 9 is not unique. Simulations suggest that ghost galaxies may actually outnumber visible galaxies in the universe. For every spiral or elliptical galaxy you can see through a telescope, there might be dozens of invisible structures lurking in the void. Our cosmic neighborhood is far more crowded than it appears. But the real question scientists have been chasing for decades is not where dark matter hides. It is what dark matter actually is. At the center of our galaxy, roughly 26,000 light-years from Earth, something monstrous lurks. We call it Sagittarius A star. It has been photographed by radio telescopes spanning the entire planet. Its gravitational influence has been measured with extraordinary precision over decades of painstaking observation. Stars orbit around it at speeds exceeding 10 million miles per hour, whipping around the galactic center like comets around the Sun. The star S2, one of the fastest objects ever observed in our galaxy, completes an entire orbit around Sagittarius A star every 16 years. At its closest approach, S2 passes within just 17 light hours of the central mass, traveling at 3% the speed of light. According to everything we thought we knew, Sagittarius A star is a supermassive black hole containing about 4 million times the mass of our Sun. The 2020 Nobel Prize in Physics was awarded in part for proving this conclusion, but in February 2026, a physicist named Crespi published a provocative hypothesis that sent ripples through the astrophysics community. What if we have been wrong the whole time? Crespi's analysis, reported in Science Daily and other outlets, suggests that the observed motions of stars near the galactic center could potentially be explained by something other than a black hole. specifically a dense concentration of dark matter. This is not the mainstream view. The Event Horizon Telescope captured an image of the region around Sagittarius A star in 2022, and most astrophysicists remain confident that a black hole is the correct interpretation. But Crespi's work raises an unsettling possibility. The thing we thought we understood, the monster at the heart of our galaxy, might not be what we assumed, and this uncertainty points to a deeper problem. For years, scientists have been hunting for direct evidence of dark matter particles. The leading theory suggests that dark matter consists of weakly interacting massive particles, known as WIMPs. These hypothetical particles would barely interact with normal matter, which explains why they are so hard to detect. Billions of them might be passing through your body right now, and you would never know. To catch a WIMP, you need an incredibly sensitive detector buried deep underground, shielded from cosmic rays and radioactive interference. The Lux Zeppelin experiment, or LZ, is exactly that kind of detector. Located nearly a mile beneath the Black Hills of South Dakota, buried in the former Homestake gold mine, LZ uses 10 tons of liquid xenon as a target. The xenon is kept at -100 degrees Celsius, perfectly still, shielded from every source of interference that engineers could eliminate. If a dark matter particle collides with a xenon atom, the detector should pick up a faint flash of light. Maybe a handful of photons, maybe just one or two. In December 2025, the LZ collaboration announced their latest results. They had achieved the most sensitive dark matter search in history, improving on previous limits by a factor of 5. The detector was working flawlessly, the data was clean, the sensitivity was unprecedented, but they found nothing. No evidence of WIMPs, no particle collisions, no signal of any kind. What they did find, ironically, was something else entirely: neutrinos. Particles streaming from nuclear fusion reactions in the core of the Sun had begun appearing in their data. These ghostly particles, produced 26,000 years ago in the solar furnace, were passing through a mile of rock and leaving faint traces in the xenon. This is actually a problem. Scientists call it the neutrino fog. At a certain sensitivity level, detections from solar neutrinos start overwhelming any potential dark matter signal. The background noise becomes indistinguishable from what you are looking for. The LZ experiment has now reached that threshold. We have made our detectors so sensitive that the Sun itself is blinding them. Future experiments will need to find ways to cut through the fog. The next generation XLZD detector, a collaboration between American, European, and Asian research teams, is already being planned. It will use up to 80 tons of liquid xenon, roughly 8 times more than LZ. But until we actually catch a dark matter particle, the substance that dominates our universe remains a ghost. And then came January 2026. Sukanya Chakrabarty and her team at UC Berkeley were not looking for dark matter directly. They were using a technique called pulsar timing. Pulsars are rapidly spinning neutron stars that emit beams of radiation like cosmic lighthouses. These signals are incredibly precise. By monitoring subtle changes in pulsar timing, astronomers can detect gravitational disturbances that would otherwise be invisible. What Chakrabarty's team found was a perturbation. Something massive was affecting the motion of a pulsar in our galactic neighborhood. And when they calculated the source, it pointed to a dark matter subhalo, an invisible clump of matter potentially millions of times the mass of our Sun, hiding relatively close to our solar system. This was the clearest evidence yet that dark matter structures exist within our own cosmic backyard. Not just a halo surrounding the galaxy, but individual clumps drifting through the void. The discovery was published in Nature Astronomy. Multiple news outlets, including Science News and Phys.org, covered the finding as a major breakthrough. We are not just surrounded by dark matter, we are sharing space with invisible mountains of the stuff. So what does all of this mean? Look up at the night sky on a clear evening, far from city lights. You might see 3,000 stars with the naked eye. Stretch that to the Milky Way, and you get 400 billion stars. Include all the galaxies in the observable universe, and the number climbs into the trillions upon trillions. Every single one of them combined is the minority. 85% of all matter in the universe is something we cannot see. It shaped the cosmic web on which galaxies formed. It holds galaxy clusters together that should have flown apart billions of years ago. It surrounds and permeates the Milky Way like an invisible ocean. And it may be drifting through your body right now, billions of particles passing through every second, utterly undetectable. We have been trying to understand the universe for thousands of years. We mapped the stars. We discovered planets. We split the atom and walked on the moon. We photographed a black hole and detected gravitational waves from colliding neutron stars. And we still do not know what most of reality is made of. The candidates keep getting ruled out. The detectors keep coming up empty. Every time we think we are close to an answer, the mystery deepens. Dark matter is not some minor footnote in physics. It is the majority shareholder of existence, and it refuses to reveal itself. This is not a failure of science. This is science working exactly as it should. We are pushing into territory that no human has ever explored, asking questions about the fundamental nature of reality itself. But it does leave us with a strange and humbling truth. We are tiny creatures on a small planet orbiting an ordinary star in the outer suburbs of an average galaxy. And everything we can see, everything we have ever touched or measured or photographed, everything we call the visible universe, is the cosmic equivalent of foam on the surface of an infinite dark sea. Something is out there. Something vast and strange and invisible, something that was here before the first stars ignited and will remain long after the last ones burn out, and it is everywhere. If you want to fall further down this cosmic rabbit hole, the video appearing on your screen right now explores another mystery hiding in our solar system. Something scientists discovered that they still cannot explain. And if you made it this far, consider subscribing. This is the kind of content we make here. The universe is stranger than we imagined, and we are only getting started.